Welcome, everyone. It is another beautiful day to watch, listen, and learn in our episode today. You are watching Math 9 on Air. This is Teacher Raymond of F. Banger National High School, and I will be your teacher broadcaster for today. So, sit back and relax. For today's episode, we will be discussing two lessons. First is about the characteristics of the roots of quadratic equation using the discriminant. And the second one is about the relationship between the coefficients and the roots of a quadratic equation. These are all based on the most essential learning competencies of the Department of Education for Week 2. So, are you ready? Let's begin. In the previous episode, solving quadratic equations using the form methods was already discussed. Can you still recall these methods? Very good! These methods are extracting the square roots, factoring, completing the squares, and using the quadratic formula. I hope you still remember those topics. For the first part of this episode, let us focus first on the quadratic formula. Have you observed in your exercises in the previous lesson that in solving quadratic equations using the quadratic formula, roots may be real or not, rational or irrational, equal or unequal? Yes, that's right! But do you know that you can easily determine the characteristics of the roots without solving for them yet? How do we do this? Well, I'm sure you are curious about that. So get ready with your pen and paper and let's explore. In the quadratic formula, this expression under the radical sign, which is b squared minus 4ac, is what we call the discriminant. This will help us determine the nature of the roots of the quadratic equation. But how do we solve for the value of the discriminant? To do this, let us follow these few steps. First, write the given equation in the standard form. ax squared plus bx plus c is equal to 0. Second, identify the values of a, b, and c in the equation. Third, substitute the values in the discriminant. b squared minus 4ac. Alright, now you already know how to solve for the discriminant. But what does this value tell us? This discriminant will actually tell us the nature of the roots of a quadratic equation. To describe the nature of roots of the quadratic equation, we use the value of the discriminant b squared minus 4ac. Now, let us take the four cases of different values of the discriminant. First, when b squared minus 4ac is equal to 0, then the roots are real numbers and are equal. Second, when b squared minus 4ac is greater than 0 in a perfect square, then the roots are rational numbers but are not equal. Third, when b squared minus 4ac is greater than 0 but not a perfect square, then the roots are irrational numbers and are not equal. Lastly, when b squared minus 4ac is less than 0, then the equation has no real roots. Now, since you already know the steps in solving for the discriminant and what the value means, let us start answering few examples. Problem number 1. What is the discriminant of the equation x squared minus 4x plus 4 is equal to 0? Let us follow the steps. Since the equation is already in the standard form, then we can now identify the values of a, b, and c which will be used in finding the discriminant. So, in the given equation, A is 1, B is negative 4, C is equal to 4. Let us now substitute these values of A, B, and C in the expression B squared minus 4AC. The expression B squared minus 4AC now becomes the square of negative 4 minus 4 times 1 times 4. The square of negative 4 is 16, and the product of 4, 1, and 4 is also 16. Performing the operation, 16 minus 16 is equal to 0. Since the discriminant of the quadratic equation x squared minus 4x plus 4 is equal to 0 is 0. Therefore, the roots are real numbers and are equal. Now, let us try another equation. X squared plus 7x is equal to negative 10. Can you solve this following the steps? Take a look at the quadratic equation. It's not in its standard form, right? Therefore, we need to transform this equation first in the form ax squared plus bx plus c is equal to 0. To do this, we have to add positive 10 to both sides of the equation and simplify. Therefore, our standard form of the equation x squared plus 7x is equal to negative 10 is x squared plus 7x plus 10 is equal to 0. Since the equation is already in its standard form, we can now identify the values of a, b, and c. Can you identify them? Very good! A is 1, B is 7, and C is 10. This time, we can now substitute the values of A, B, and C in our discriminant B squared minus 4AC and simplify. So, we have the square of 7 minus 4 times 1 times 10. The square of 7 is 49. The product of 4, 1, and 10 is 40. Then, 49 minus 40 is 9. Since the discriminant of the quadratic equation x squared plus 7x is equal to negative 10 is 9 and is a perfect square, therefore, the roots are rational but not equal. Did you get this right? Very good! Now, let us practice more. You are given 20 seconds to do this. Are you ready? What is the discriminant of the equation x squared plus 6x plus 3 is equal to 0? 20 seconds starts now. Okay, time is up. Let us see if we got this correct. The equation is already in its standard form. Therefore, we can easily identify the coefficients as A1, B6, and C is 3. Evaluating B squared minus 4AC, you will arrive at the discriminant of 24. And since 24 is greater than 0 but not a perfect square, then the roots are irrational numbers and are not equal. Okay, did you get the correct answer? Very good! Alright, let's have one more equation. This time, x squared plus 2x plus 5 is equal to 0. Solve for its discriminant and describe the nature of its roots. You have another 20 seconds to do that. Okay? Time starts now. Okay, time is up. What's your answer? If you got negative 16, then you are correct. Since the discriminant is negative 16, then the equation x squared plus 2x plus 5 is equal to 0 has no real roots. Okay, let me show you the summary of the answers that we had in our previous examples. At this point, you have already learned about the use of the discriminant in characterizing the roots of a quadratic equation. I'm sure that you will now be able to answer correctly the different activities in your module. Welcome back! You are still tuned in to Math 9 on air. A while ago, we have discussed that the b squared minus 4ac in the quadratic formula is our discriminant, and it can tell us the nature of the roots of a quadratic equation. This time, we will also find out that the quadratic formula can also give us information about the relationship between the coefficients and the roots of the equation itself. Now, do you know that the sum and product of the roots of a quadratic equation can be determined using the coefficients a, b, and c without solving for the roots? That's right! This can already be determined. But how? Let us recall that the roots of the quadratic equation can be determined by using the quadratic formula. And so, to get the sum of the roots in terms of the coefficients a, b, and c, the formula is derived as x sub 1 plus x sub 2 is equal to negative b over a, while the formula for the product is x sub 1 times x sub 2 is equal to c over a. Let us try this. Find the sum and the product of the roots of the equation. 2x squared plus 8x minus 10 is equal to 0. Now, since the equation is in its standard form, we can now identify the coefficients, and we have a is 2, b is 8, and c is negative 10. Substituting these values in the formula for the sum and product of the roots of the equation, we now have the sum of negative 4 and the product of negative 5. To check if you got the correct answer, find the roots of the equation using any of the methods of solving quadratic equations. Then, determine the sum and product of the roots. Did you understand? Let's try another one. We have x squared plus 7x minus 8 is equal to 0. Again, since the equation is already in its standard form, and so we have a is 1, b is 7, and c is negative 18. Substituting again these values in the formula, we arrive at a sum of negative 7 and a product of negative 18. Alright, I hope you get that too. Now that you know how to solve for the sum and the product of the roots, then you will know that you can also determine the quadratic equation given the roots. It can be recalled that the quadratic equation in the form ax squared plus bx plus c is equal to 0 can be written in the form x squared plus b over a x plus c over a is equal to 0. Therefore, this is the same as x squared minus sum of roots x plus product of roots is equal to 0. Let us try to explore this. Find the quadratic equation if the roots are 4 and negative 7. How do we do this? First is to find the sum and the product of the roots. So, substituting the values for x sub 1 and x sub 2, the sum of the roots is negative 3. while the product of the roots is negative 28. Next is to substitute the sum and the product of the roots in the form x squared minus sum of roots x plus product of roots is equal to 0. Since the sum is negative 3 and the product is negative 20, therefore, our equation now becomes x squared plus 3x minus 20 is equal to 0. Did you get it? Let's try another one, where there is a root which is a fraction. The problem is to find the quadratic equation whose roots are negative 1 and 3/2. Okay, let's follow the same process. That is, to get first the sum and the product of the roots. So, what do we have? Substituting the values for x sub 1 and x sub 2, the sum of the roots is 1/2, while the product of the roots is negative 3/2. Now, after we get the values of the sum and product of the roots, let us now substitute this in the form x squared minus sum of roots x plus product of roots is equal to 0. Since the sum of the roots is 1/2 and the product of the roots is negative 3/2, our equation becomes x squared minus 1/2 x minus 3/2 is equal to 0. Now, to eliminate the fractions, we simply multiply both sides of the equation by 2. Therefore, after simplifying, our equation now becomes 2x squared minus x minus 3 is equal to 0. You get this too? Very good! At this time, we have already discussed about the relationship of the coefficients and the roots of the quadratic equation. Always remember that the sum of the roots is equal to the negative of b over a, while the product of the roots is c over a. It can also be recalled that the quadratic equation in the form ax squared bx plus c is equal to 0 can be written in the form x squared plus b over a x plus c over a is equal to 0. Therefore, this is the same as x squared minus sum of roots x plus product of roots is equal to 0. That's it for today, learners. I hope that you were able to learn a lot of things from today's Math Night on Air. Don't forget to answer the activities in your modules, because the only way to get better in math is to practice, practice, and practice. If you have questions or clarifications regarding the lessons in your module, your assigned Math 9 teachers will be happy to assist you. Once again, this is Teacher Raymond, and now signing off. Bye-bye!